Good evening, everyone. Very good evening. Am I audible to you all? Let me know if I'm audible to you. Okay, guys. Okay. So, you guys have gone through the notes and the programs? Yes? Notes and the programs you guys have gone through? Okay, guys. So, any doubts in previous concept? Anywhere, any doubts you have in the previous concept, you can let me know if you have. In case if you have any doubts in previous concepts, you can let me know. You guys are clear with object class member to string equals and hash code? Notes are not accessible. Why? I have sent you notes. Why it's not accessible? Ma'am, notes are not accessible. But why? How many of you are facing this issue? You are not able to access the notes? How many of you are facing the same issue? It shows corrupted. What corrupted it is? Okay. Okay. How many of you are facing the same issue? One. Saurabh Sanket is two of you are facing this issue. How many of you are facing the same issue that you are not able to open the file? Whatever the PPT. Okay, so if you guys are having issues, you can contact a technical team. Yeah, Vandana, you can carry on. Okay, only for Sanket and other. So, one second, Vandana. So, Sanket and Saurabh, you can contact I mean, whatever technical team. Okay, and you can resolve it. Okay. Yes, Vandana, you can carry on. Vandana, you can carry on. Yes, you can carry on, Vandana.
Thank you, ma'am. Um, Good evening, guys. This is Vandana from the announcement team. Is my voice is audible, guys? Today, I'm here to announce the requirement, guys. Before that, there is a small update regarding the QTalk app. Guys, I, to log into the QTalk app, you need to use the same credential, guys, which you are login for the classes. Um, by using the credential which you are using the credential, same credential has to be used for the QTalk app also. Okay, I hope everyone got it. I'll be moving for the requirements. I'll be sharing the screen. Hope the screen is visible. This is generic requirement. Please take the snap of this slide. It's a offline interview, and both testing and development students can apply for this requirement, and it's based on the degree. Once the class done, go through with the requirements thoroughly, guys. If you're eligible within half an hour, you have to share the details and get registered for the requirements. I'll be moving to the next slide. This is testing requirement. Please check the snap of this slide for the testing test first designation. Both online and offline interview will be there. For the second, it's a offline interview. I'll be moving to the next slide. This is development requirement. Please check the snap of this slide. I'll be stop sharing the screen. Guys, if you have any queries, please let me know. Okay, guys, that's it from my end for the today's class, guys. Thank you, guys. Thank you, ma'am.
Okay, guys. Sim file is also not open. Why, guys? Why? It's in a text document, okay? It's in a TXT format. I have copied everything and I've put in one text document. It's not in PPT format or PDF format. It's in text format. It will open for you. Okay, so if you are not able to open, see, I will be sending in any format, guys, like PPT. I'm not sending you, mostly in PDF and in a text document or in a image format. Out of these three, in another format I will send you, mostly PDF only I'll send, most of the time PDF. And to see your programs, I'll just send in JPG format, that's in a pic or a photo format. And some in case I want you guys to take the full code, I want you to take means, then I'll be sending it to you in the text document. Can you resend, please? Okay, people who want notes, you can tell me what notes you want. Okay, you can respond to me on the Q talk. Okay, so whichever notes you want, I'll be giving it to you. Okay, so make sure you ping me on Q talk. Don't forget. Okay, guys. Any doubts from the previous concept? You guys have understood everything? Two string, two string equals hash code. Everybody understood? Okay, okay. I think people have understood. If you have any doubts, okay, guys. Okay, okay. So today, what we'll do is hash code again with one more program. Um. Okay, no problem. So hash code, I hope you guys have gone through notes and all. Okay. So hash code we will again take with one more example. Okay. So that example we can go for, okay, whatever we want we can take. Any object we want we can take. Okay. So okay, any object. Suppose if we take okay, we will do one example for hash code. So we'll go for Eclipse. Okay, I hope everybody are using Eclipse without any problems. Are you guys able to freely uh, locate your class, package, project, how to create class? Any issues you have? Any issues you have? Okay, guys, that's good. Okay. Okay, so currently we are in E23 project, and under SRC only you will have all your packages. Okay, so we were under your object class programs. Now let us go for creating one class here, that is your pen class. Class pen. Okay, class pen. In the class pen you will have attributes. Okay, you can take color of the pen, that is string color of the pen, and int price of the pen. Now let us create constructor easily. Let us create constructor easily. See, you can go to source. You can go to source here. You can generate constructors using fields, and then you can, if you see tick mark here, okay, fine. If you don't want this any one of it, you can customize it. You can customize both of it. But currently we want both of the color and price attributes. After that, we'll go for generate. So we have one pen constructor. We have pen constructor here. Now now after this, so we have color, price, and constructor. Now we shall go for overriding to string. So here there is an option generate to string. Above generate constructors using fields, there is a generate to string. Just click on it. You don't have to override inherited methods. You just have to go for fields, that is color and price, and we'll go for generate. Okay, we'll go for generate. Now after overriding here, okay, after overriding here, so here for the pen object you can see there is a color and the price both. Okay, So this is how you override toString. You already know. We can change this implementation if you want. Next, we'll go for source. We'll go for generate hash code and equals. So both generate hash code and equals. See here, see here. What we have done is, so yeah, get plus. Okay, this white. Okay, something else has come. Just a minute. Okay, so we shall go for okay, generate hash. One second, one second. Um, generate hash code and equals hash. Um, okay, generate. Okay, this might be little difficult for you to understand. The easiest way is whatever we will do. Okay, so this will you have to understand. This means again you have to go through so many things, but this is the easiest way. Code is also less, and you can understand in easiest way. Okay, only for okay, hash code you have here. Don't want. Okay, it will be again big thing for you. So let it be here. Okay, let us skip this. So equals you have gone for. Okay, object O equals of object O. Now currently we are in equals. Currently we are in equals method. Now what we have to do is we have to downcast this object into the pen to access one past object or past value. Okay. So here what we have to do? First you have to downcast pen p is equal to pen type, we have to convert into object. Okay, now we have to return, we have to return this dot p. Okay, so attributes we can take as we have color and price. Listen carefully, we have both string and int. We have string also, we have int also. We have string also, we have int also. So since we have string and int here, since we have string and int here, we have to go for equals. Equal to also you can go for color, I mean for the string, or dot equals to also you can go for string, but here in the int you have to go for equal to operator. Okay, so here this dot color dot equals of p dot color, and and for the pen price, this dot price equals to p dot price. Done. Now after this we'll go for overriding hash code. I mean hash code is override. We'll go for overriding hash code. Public int hash code method. Hash code method. So here we'll be returning objects dot hash of, see, based on both the objects, based on color also. Okay, based on color also and based on price also, you have to compare. Okay, so yes, we have hash code. So currently we will make it as hash code is not there. I will explain you later. Now let us go for main method here. So inside main method, let us create an object for pen. Okay, pen p1 is equal to new pen of no argument construct. I mean parameter is construct. Pen color black. Pen color black. And pen price, okay, maybe 40 rupees. Next, one more pen object. Pen p2 is equal to new pen of constructor. Blue color pen. Blue color pen. The price of the pen will be 10 rupees. Next, pen p3 is equal to new pen of, now we'll go for pen color as a black, and the pen price will be around 40 rupees. Okay, now listen everyone, listen carefully here. Ma'am, source and this options are present in notepad or not? Source. No, no, no. Where from where you will get in this notepad? No, in notepad you will not get. There is no options for that. In Eclipse only it is present. In notepad it is not present. You'll not get this in notepad. Only in Eclipse you'll be getting it. Okay. So we are having pen P1, pen P2, P3. Okay. Now we have three different objects. We have we have three different objects. Okay. And next what we'll be doing here is, now we shall start comparing using equals. Since equals is already overridden, when you are comparing, it will compare the data. Yes, we have to type all these things. In case if you are using notepad, everything you have to type by yourself. Nothing you'll get there. Okay. So P1, P2, P3, three objects we have. Suppose if you compare, if you print P1, P2, P3, surely you will be getting the data. Okay. So let me go for printing this P1. Next P2. Okay. And then P3. So if you can see here, we'll be getting all the output based on two string. Pen of whatever the color we have, whatever the price we have, now we'll be getting it. Can you see? All of pen objects only. Color black, price 40. Color blue, price 10. Color black, price 40. Okay, fine. Next. Okay, so next let us go for equals. So within a println statement, we will check here if p1 dot, that is current object dot, equals of past object p2. The current object you can use this dot p1. Okay, this dot whatever the element we have. But for passing object, for this element to be passed here, like to validate this and to compare this, of course we have to downcast one object. We have to take, we have to convert into a penny type and you have to compare it. Okay, so here p1 dot equals of p2. Now you tell me, will it give true or false? Everyone, equals, can you tell me, will it be true or false? P1 dot equals of P2. Okay, so why is it false? It is false because the data is different. Data is different. Okay. So since the data is not matching, so what do we get? False. Okay. Now we shall go for P1 dot, or we shall go for P2 dot equals of P3. Now this one, what about line number 40? Of course it is false. Yes. Next, it is true. How, Samiksha? The data is different. It can't be true. Okay. So let me show you here. See, it is false. Okay. It's okay. It's okay. No problem. Next, P1 dot equals of P3. Okay. Now you guys tell me. Yes, Sank. P1 equal to P3 is true. Yes, correct. Why? Because the data are matching. Both string and int are matching in the pen P1 object and pen P3 object. Okay. In P1 and P3, the data are matching. So here it will give true. This is about your equals method. And you have to see when it is giving true. When it is giving true, when P1 and P3 are used in the equals. When P1 and P3 are used in the equals, it is giving true. Equals method is giving true. Now what we'll do is, we'll try to go for printing hash code for all the objects. P1 dot, P1 dot, P1 dot hash code. Next, we'll go for P2 dot, P2 dot hash code. Next, P3 dot hash code. We have three, P1, P2 and P3. P1, P2 and P3. See, now all these hash codes, they are belong to different object. Remember, we have not overwritten hash code. Currently hash code is not there. We have commented it. Hash code is not there. Currently it is not visible to compiler. Now if you're printing hash code, okay, you will be getting the unique integer id for all the objects. P1 you will get one unique integer id, P2 you will get one unique integer id, P3 also you will get one unique integer id. Let me show you here. Can you see? These three are having a different unique integer ids, like unique integer ids for every object it has created. But now after overriding, now let me override here. See, while overriding, you have to go for objects.hash of this method. Why? Because in the objects class only, you have this hash method, and you can mention how many ever attributes you want to compare. Full attributes you can mention. So currently we have a color and the price. So we have mentioned color and price, and based on that, it is matching. And remember, any two objects or any objects with the same data, any objects with the same data, it will give for all the data it will be giving one unique id. Okay, now we can see now for p1 and p3. For p1, currently for p1 and p3, yes Samiksha, correct. For p1 and p3, one id will be there, and for p2 one more id will be there, because now it is overwritten. It will not see what is the reference variable. Okay, it will not see what is reference variable. It will see what is the data after overriding. After overriding, it will see what is the data here. Data for the p1 object and p3 objects are same. Data for p1 object and p3 objects are same. Since they are same, for this p1 and p3, there will be one unique integer id given. For every data, for every unique data, one unique integer id will be given. So for the object p1 and for the object p3, you will have one unique id, but object p2 you will be having one different id. Okay, so here let me show you. Can you see here? This id, p1 id and p3 id are same. Why? Because they have same data. Because they have same data. Since they have same data, here we are able to get the same unique integer id. Same. It is also same. It is also same. Both are matching. Okay. So we are able to get the same integer id because these two objects are having same data, irrespective of it's from different objects, but still they're having same data. Okay. This is about your hash code. Excuse me. Okay. Okay. I hope you guys got it. Everybody understood what is hash code, how we have to use it. You guys got it? You guys understood hash code, everyone? Okay, guys. Okay, okay, yeah. Okay, now we shall go for our third principle of whoops. Now, can anyone tell me what is the third principle of whoops? Third principle of whoops. Samiksha, polymorphism is already done. Yes. So polymorphism is the third one. Fourth one is, yes, abstraction is the fourth one. Yes. Fourth principle of our whoops is abstraction. Okay. Okay, so let me ask you one question. Okay. So here, okay. Okay, assume you have gone to an ATM. Okay. You have gone to an ATM only, you take, assume. Now here you have seen the monitor here. Why? Because you want to withdraw some amount. Okay, and you're seeing some details here. Okay, so here some buttons will be there which you can choose, and here also side there will be buttons, and here some name will be there, here some ad will be there. Okay, see guys, As a user, okay, before you don't know Java, before you don't know any programming language, what you used to do? As a person, you used to go to ATM, okay, insert card, give all the necessary information, tuck 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 tuck, you'll give all the information, right? After giving all the information, you will withdraw cash and come off. You withdraw cash and come off. Now you tell me, instead of showing these options, what if I write Java code? What if I write Java code? See, instead of these instructions, whatever in the boxes, in a buttons format, you got instructions. No. Instead of that, what if I use Java code? Now, who and all can withdraw amount? Who and all can communicate with the ATM? Yes, can you tell me who and all can communicate with the ATM now? Who can communicate? Yes, programmers only will be able to communicate to the ATM. As a normal people, we cannot communicate with the ATM because when we don't know programming, we used to go to ATM, withdraw money, just clicking buttons and giving some passwords and all. After inserting card, we used to withdraw money and come back. And if it was in the Java code, obviously we would have not even entered into it. We would have not even thought about that, right? We would have not even thought about that. So because of this only, this is unwanted thing. What user wants only these buttons. If user understands what is there in simple words, that is enough. User don't have to know Java code behind this. What is the code behind this? What is the programming code behind this ATM? As a normal person, we don't have to know. Any normal person don't have to know what is the code behind this ATM, but normal person wants to know how this works. Use like white box testing. White box testing. Okay, you need to clean and easy getting data person needs. Yes. Okay, in testing language you can tell it, but here it's like you are you are hiding the unwanted thing and just to showing what is necessary. Are we doing the same thing? Yes, we are doing the same thing. We are hiding what is not necessary. This Java code does the user need Java code? No, user don't have to need. Not only programmers are there in this world. Many people are with different jobs are also there. Okay, it's not only programmers are there. So as a user, you don't have to know about the Java code, but you have to know what is shown. Like you have to only show what is useful for the user. You have to only show what is useful for user, and you have to hide what is not necessary. What is not necessary you have to hide, but what is needed only you have to show. Okay, so this design process of hiding whatever is not needed and showing whatever is necessary is called as your abstraction. So here usually behind these buttons, okay, these buttons are method call statements. These buttons are method call statements. When you click on one button, that method will be called and that task will be done. When you click on this button, that method inbuiltly one method will be called and the task will be done. For every method, one buttons will be given. Now here we don't have to know the code behind that method, but we want to know the function. We just want to know the declaration or functionality of the method. See, if you take a method here, so method has a access modifier, method has a modifier, method has a return type, method name, and formal arguments, and method has a method block. So here, if you are not showing the implementation of the method, if you are just showing the functionality or the method declaration, this is called as abstraction. Okay, so you're only showing the functionality or method declaration. You can call it as method declaration, okay, or you can call it as functionality. You don't have to know what is written inside this method. What is the instructions written inside method? You don't have to know. What you have to know is the name of this method and what it will do. You just see, suppose you can go for start button. You will know what to do with start button. You will click on it and it will start whatever wanted to start. Here the start is a method. Start is a method. That the method you are just it is just shown here. Okay, so here this everything is in the form of a functions. Everything is in form of functions, okay, or methods. If you are hiding, if you are hiding the implementation of the method and showing only the functionality or just showing the method declaration, it is called as abstraction. It is called as abstraction because user don't have to know what is the code you have written inside the method. User has to know what is the task that will be done with this function. User has to know what is the task that will be done by the function, and user don't have to know the code behind it. User user don't have to know the code behind it. This is what we call it as abstraction. Okay, so abstraction means okay, it's a a design process of hiding the implementation hiding the implementation design process of hiding the implementation and and showing only the functionality showing only the functionality. That is what we call it as only method declaration. Okay, only declaration will be shown, okay, to the user. Okay, is called as your abstraction. Is called as your abstraction. Abstraction means it's a design process of hiding the implementation and showing only the functionality to the user. Showing only the functionality to the user is called as abstraction. So why we are hiding implementation means user don't have to know what is the code written behind that concept. User don't have to know the code. What user has to know is only only the name of that method, the task of that method, just name of that method user knows, means that's enough. So we want to show only the functionality and you have to hide the implementation. You have to hide the implementation and showing only the functionality, that is method declaration, to the user is called as abstraction. Okay, so how can we achieve this abstraction in our Java? How can we achieve this? So we can achieve this abstraction in our Java, okay, through abstract classes through abstract classes and interfaces. We can achieve we can achieve abstraction in our Java with the help of abstract classes and abstract interfaces. Okay, now here we can provide implementation to this abstract classes and interfaces, okay, with the help of inheritance and inheritance and method overriding. Method overriding. Method overriding. Okay, so here in Java we can achieve abstraction with the help of abstract classes and interfaces. And to the abstract classes, there inside that there will be abstract methods, and we will provide the implementation to the abstract component with the help of inheritance and method overriding. See, inside abstract classes, surely abstract methods will be there, and for them using inheritance and method overriding, we will be providing we will be providing implementation. Implementation means very simple. We will be providing method body. We will be providing method body. We will be providing method body. Okay. So for understanding this, we have to first go and understand your what is abstract keyword. So abstract is a normal keyword. Abstract is, one second. Abstract is, it's one keyword. Abstract is a keyword, as well as it is a modifier also. Abstract is a keyword as well as a modifier. Okay, this abstract is applicable for classes as well as methods. Applicable for methods and classes. Okay, This abstract, this keyword or a modifier abstract is applicable for methods as well as classes. Methods as well as classes. Now let us see if it is applicable for methods, how it will be. Okay, where it will be prefixed and how it will behave, everything we will see now. Okay, see, a method which is prefixed with abstract modifier is called as abstract method. Abstract method. Okay, abstract method means any method you take. Any method you take. If the method is prefixed with the abstract keyword, if a method is prefixed with the abstract modifier or abstract keyword, then you can call that method as abstract method. You can call it as abstract method. Okay, and here we call this abstract method as a incomplete method. We call this abstract method as incomplete method. But why? But why? Why we call why we call abstract method as an incomplete method? Why? Because abstract methods doesn't have body of a method, or you can call it as implementation will not have. Implementation of the method or body of the method will not be there for the abstract method. It will not be there for abstract method. Okay, and here let us see the syntax to create a abstract method. Syntax to create an abstract method. Syntax to create an abstract method. So we have to know what is the syntax to create a abstract method. Okay, so syntax to create a abstract method is very simple. Listen carefully. First we shall go for access modifier. Then in the place of modifier we have to mention abstract. Then return type we can mention return type, and you can go for method name, and you can also provide formal arguments. And at the end, listen carefully, you have to go for semicolon. You have to go for semicolon at the end. Okay, at the end you have to go for semicolon. But why we have to go for semicolon here? Because abstract method doesn't have body. Abstract method doesn't have body, or doesn't have implementation, or doesn't have method block. Okay, abstract methods don't have method block. That is implementation. Abstract methods doesn't have implementation. Only method declaration statement only it will have. Only declaration will be there. Only declaration will be there, and no functionality. I mean implementation. Declaration and functionality both are same. Declaration or functionality, and no implementation. No implementation. So because of this no implementation, your abstract method is called as incomplete method. Incomplete method. Abstract method is called as incomplete method because abstract method abstract method doesn't have method body. Abstract method, any method which is prefixed with abstract keyword is called as abstract method, and abstract method doesn't have a method body. That is why it is called as incomplete method. Incomplete method. Okay, now suppose in one class assume we have written an abstract method. An abstract method we have written. Now who will be able to give implementation for this method? Who will give the implementation for this method? Suppose it is in class A. Now the class which is inheriting abstract class, suppose class B is inheriting abstract class B is inheriting abstract class. So when it is inheriting abstract class, okay, when it is inheriting abstract class here this abstract method also will be inherited. This abstract method also will be inherited. Okay, so here what all the abstract methods will be there in a parent class will be inherited to child. Now this child class should give the implementation. this child class should give the implementation for that class, I mean for that method abstract. For that abstract method, child class only should give implementation. For parent class abstract method, the class which is inheriting parent, that is any child class of the class can give inheritance, I mean can give implementation for this abstract method. Okay, so let us understand some more about your abstract class. See guys, in a class you can just have an abstract class and don't have abstract method. You can have an abstract class, you can just be like that. But in case if you don't have this abstract, in case if you don't have this abstract keyword, okay, and now you just have a normal class and you write one abstract method, that is public abstract void dance method, now semicolon. This is a abstract method. So whenever a class contains at least one abstract method. So this dance method is abstract because this dance method is prefixed with the abstract method. Okay. Now a class can be abstract class and have no abstract methods. A class can be abstract class. A class can be abstract class and have no abstract method. But if a class is having at least one abstract method, if a class is having at least one abstract method, if one abstract method is there also, you have to make the class as abstract. You have to make that class as abstract class. You have to make the class as abstract abstract class. Okay, so next, after this, let us directly get into your Eclipse and understand how this is going on, how your abstraction is going on. Okay, so let us create one package here for the fourth principle of whoops, that is abstraction. Okay, we shall go for creating abstraction. Okay, next, after this, after this, now now we will create one class. Okay, we will create one class. See, currently we have to create one abstract class. So can you see a space here? Can you see a space, I mean can you see a button here, abstract, where I am clicking and unclicking again? Can you see abstract here? Abstract, yes. So currently, if you want to create any abstract class, first way is you can just click on this abstract and you can name it as a, suppose if you are going for one bike class bike. Okay, so now you got a abstract class. Now you got a abstract class. If you don't want this class to be abstract, just remove it and it will be as a normal class. If you don't want to make any class as an abstract class, just leave it as it is. Don't worry, don't go for all those things. Just if you want to create a class, directly create it. Just click on C plus, directly give the name, whatever name you want, directly enter. Okay, don't worry about that. If you are confused, if it's confusing, don't worry about that. Now, if you want to make any class as abstract, you can make it as abstract like this. Directly you can write. Directly also you can write. Go with this. Okay, don't go with that. Go with this. So currently now let us create one abstract class and the class name is vehicle. We have created a child class here. Okay, so first we shall create one abstract class. So we shall go for abstract class vehicle. Okay, in an abstract class vehicle we have one method called as number of wheels method. So the method name will be public abstract, return type will be int. You can just tell get number of wheels method, get number of wheels method, semicolon. So what you are seeing is an abstract class with one abstract method. See, if you are not having any abstract, if you don't have, okay, if you don't have any abstract method in abstract class, if you don't have any abstract method in abstract class, that is fine. But if you're having a normal class, if you're having a normal class and along with that you have one abstract class, I mean one abstract method, you have any normal class, if it is having at least one abstract method, any normal class, if it is having at least one abstract method, then it's mandatory to make that class as an abstract. Can you see here? Make type vehicle as abstract. Why? Because this abstract method should be present only in the abstract class. Abstract methods should be present only in the only in the abstract classes. Only in the abstract classes it should be done. Okay. Next. So what we have to do now is we shall inherit this vehicle class, because see currently this get number of wheel method doesn't have a method block or method body or implementation. It doesn't have, but we want to give implementation for this abstract method. We want to we want to give implementation. We want to give implementation for this abstract method. Since we have to give implementation for this abstract method, we will just inherit. Okay, we'll go for extends class vehicle. Okay, now your bike class, for your bike class now. Okay, for your bike class now, what you have to do? See, you have a parent class, parent abstract class. Now you have parent abstract class. Now you have parent abstract class, and now currently you have one child class, that is bike. For this abstract class vehicle, you have one child class bike. For this abstract class vehicle, you have one child class, that is bike class. Okay, child class, that is bike. Okay, next. Next, here, see, if you are inheriting any abstract class, if you are inheriting if you are inheriting any abstract class, you will have two options, guys. You are inheriting any abstract class. Currently this bike class is inheriting this abstract vehicle class. Now this child bike will have two options. Child bike will have two options. Either either it can override this method, either it can override this method and give the implementation, or if this bike class doesn't like to give implementation, it can make itself as an abstract. It can make itself as an abstract. Listen carefully. Currently we have one abstract class vehicle, naming vehicle. Now our child class extends vehicle. So bike class extends vehicle here. Now for the bike class there is two options. Since it's inheriting vehicle class, the abstract method is currently present in bike class also. Abstract method is present in bike class also. Okay. Now, okay, abstract class. Okay, abstract method, this get number of wheels method is present in bike class also, is present in bike class also. So here we have two options. See, compiler only gives two options: add unimplemented methods, add add unimplemented methods. That is, this method is an unimplemented method. You don't have any implementation for this get number of wheels method. Okay, and you have two options. Either you can go for implementing the unimplemented method, or you can override. I mean, you can make the guys, 1 second, I'm getting a call. 1 second. Excuse me, guys, I just got a call. Excuse me. Okay. So here we have a class vehicle, right? You have an abstract class vehicle. Now any child class, any class which is inheriting vehicle class is also inheriting the abstract method. Is also inheriting abstract method. When it is inheriting abstract method by default, there will be two options given for this by class. Either it can give implementation for this method, for this abstract method. It can give implementation for this abstract method, or what it can do is if it doesn't want to give, if this bike class doesn't want to give implementation for the get number of wheels, it can make itself as an abstract class. It can make itself as an abstract class. Why? Because whenever you're inheriting an abstract method from an abstract class, from abstract class you're inheriting get number of wheels method into the bike class. So bike class has two options. If you don't want to override or give implementation, that is to give a method block, I mean body for this method. If you want to give a body for this method, you can implement it. But if you don't want to give method block or body for this method, you can make this class as an abstract class. Okay, so first we'll go for first option. See this bike class, if you're implementing it, add unimplemented method. So what we are doing, we are overriding non-static parent class method, non-static abstract parent class method, that is get number of wheels method. Get number of wheels method. Here, here now currently we can implement it and we can return some data. Listen carefully here, everyone. Parent class abstract, and parent class abstract has one child, I mean one method. Parent class parent abstract class, vehicle abstract class has one method, that is abstract method, get number of wheels method. Next, child class bike, normal class bike extends abstract class, that is vehicle. It will have two options. It can override this method. That means, see, this method is called as this line number 5. This method is called as incomplete method because it's an abstract method. We have to give the implementation. We have to give implementation. Okay, so if you want to give implementation, you can just override that method, and you in the implementation you can write whatever you want. Okay, you can write whatever you want here. Now, this is one way. For any class which is inheriting a abstract class, for any class which is inheriting abstract class, if there is any abstract methods present, those also will be inherited. Now your compiler will force this bike class to do two things. Either you can make this class as an abstract class, or you can implement that abstract method. Either you can make this class as an abstract, you can make this class as an abstract, or else you can implement that method from the parent class. That means you can give body for that um, body for this method which is from the parent class. That means you can override. Okay, so this is the two options. You can go for child class. Okay, this is the two options. You can go for the class child. Okay, next, listen carefully. Parent class vehicle, it's an abstract class. It has an abstract method, get number of wheels. Class bike is inheriting vehicle class, so this method also will be inherited, get number of wheels. When it is inherited, since it's an abstract method, okay, since it's an abstract method, your compiler will force this bike class to do two things. Either it can make this class abstract and not give implementation. Second option is it can override that method and give the implementation. Second option is you can override this method which is from the parent class, you can override this method, and you can give implementation, that is a method block or method body for this method. What is the second option? This is the, this is the second option. Now what is the first option? First option is, in case you don't want to give implementation for this method, you don't like, okay, assume you don't like, you don't want to give implementation, very easy, you can make this class as an abstract class. You can make this class as an abstract class. Return 2. Why return 2 is used means, for the bike we have two wheels. For the bike we have two wheels. We have taken vehicle, for vehicle we have wheels, right? And for the bike we have two wheels. Do we have three or multiple? Okay, I think for the Mercedes bike there is more number of wheels, right? Like more wheels combined for Mercedes. We are just taking for the normal bike which has two wheels. Okay, so a parent class vehicle has one method, get number of wheels, that is abstract method. And child class, if child class doesn't like to give implementation for parent abstract class method, it can just make itself as an abstract. It can make itself as an abstract, and next level of child. Okay, next level of child, that is, assume class, um okay, we'll go for bikes. Now class bikes extends bike. Class bikes extends bike, assume. Okay, step into this. Okay, now here, see whom we are inheriting, abstract method, abstract class bike. We are inheriting a abstract class bike. Here we are inheriting bike class. When you're inheriting bike class, obviously this method is present in this vehicle also, it is present in this bike class also. Now currently it is present in this bikes class also. currently currently it is present in bikes class also. Since it's present in bikes class, okay, two options is given for this. Two options is given for this. Either it can make itself as an abstract class. It can make itself as an abstract class and the next level of child can give implementation. It can make itself as an abstract class. Okay, the normal class can make itself as an abstract class. And second option is you can go for implementing that method from the parent class. That is, add unimplemented methods. You can just return two here. You can return two. Okay, so this is how you can do it. So here, 1 second. Okay. Now we have class vehicle as an abstract. Listen carefully. You will get confused already. So make sure you hear it properly. You have a abstract class vehicle. We have abstract method get number of wheels. Now bike class is inheriting the bike class is inheriting the vehicle. Bike class is inheriting the vehicle. See, you have a class vehicle here. See, you have to make any class as an abstract. You can just give an abstract keyword for that. If you want to make any class as an abstract class, so suppose I want to make this class vehicle as an abstract. So I'm prefixing abstract to the vehicle class. I'm prefixing abstraction to the vehicle class. Now, I have to make this method as an abstract. So I'm just prefixing abstract keyword for this method. And I am not having any implementation for this method except this semicolon. Okay, abstract class means a class which has abstract keyword in it in the class declaration statement. You have a class vehicle here. For this class vehicle, if you have abstract keyword, it's called as abstract class. And in an abstract class, you can have abstract methods. So the methods will be in this format: public, abstract, any return type, and any method name. At the end, you will have a semicolon. So this is your abstract method. This is abstract class. This is abstract method. Okay. So let me write it here. Abstract class. And this is your abstract method. This is a abstract class and this is a abstract method. Abstract class means any class which is prefixed with abstract keyword is called as abstract class, and any method which is prefixed with abstract keyword is called as abstract method. And here we have an get number of wheels method, and we are inheriting this vehicle into the bike. We are inheriting this class abstract class vehicle into the class bike. Okay, after inheriting, since it's an abstract class, the compiler forces us to give the implementation for this. Two options is there. You can give implementation or method body for this get number of wheels method. You can give implementation for this get number of wheels method, or or you can make this class as an abstract class. Two options are there. When you are inheriting an abstract class, for a normal class, when you're inheriting an abstract class, you have two options. Either you can make the class as an abstract when you don't want to give implementation for this get number of wheels method. When you don't want to give implementation of the for this get number of wheels method, you can make this class as an abstract and the next level of class can give implementation. But in case if you are not making this class as an abstract, you have to implement this method. You have to implement this method. So now let us implement it. Okay, let us implement. So this is how will be implemented. Okay, as the bike contains two wheels, so we'll return two. Okay, next after that we shall go for main method and we'll create an instance for the class bike. You can't create an object for class vehicle because it's an abstract class. For abstract class, you can't create an object. For an abstract class, you can't create an object. Okay, but for the normal class, that is bike, we can create an object. So suppose if you take class bike b is equal to new bike of no argument constructor. Now, in the println statement with the reference variable b dot get number of wheels, we can easily call b dot get number of wheels method. Now you will be getting 2 in the output. Now you will be getting 2 in the output. Can you see here? Yes. So here for the child class bike, if you are inheriting parent class with the method, okay, obviously when you're inheriting parent class, all the methods will be inherited. And there is two options for this child class bike. You can make itself, okay, this child class can make itself as an abstract class and not give implementation to any method, any abstract method. And second option is this bike class can give implementation for this abstract method. Bike class can give implementation for this abstract method. Okay, so that is what we are overriding here, and we have given implementation. Okay, and we have written some value. So if you're creating an object for the bike and calling the get number of wheels method, you will obviously get 2. Why? Because we have written 2 here. Okay, so returning is 2, so only you are getting 2 here. Okay, next, you can even upcast. Okay, you can even upcast. Suppose okay, so you can go for vehicle v is equal to new bike of no argument constructor. Now, with the help of v dot get number of wheels method, we are also will get 2. So why, what's happening here? See, though LHS side is an abstract class, though LHS side is an abstract class, using the reference variable, we are calling get number of wheels method. That is true. But in the RHS side, runtime polymorphism, in method overriding, you have to go for runtime polymorphism, and RHS side, who is the currently executing object? Who is the currently executing object, and that object members will be executed. So currently bike is executing, so get number of wheels method, you'll get 2. So two two outputs will be getting, so 2 and 2, 2 and 2. So let me explain you here. It's not confusing, it's that you are not listening. Okay, let it be, I'll explain you a number of times, no problem. Okay, see, listen carefully. If a parent is an abstract class, okay, if parent is an abstract class, so abstract vehicle. Okay, now child is a normal, child class bike is a normal class, and we have one dance method here, abstract method, abstract dance method. Now when you're inheriting this vehicle class into the bike, obviously you're inheriting all the abstract methods also. Who are not inherited? Only private members and constructors are not inherited, but abstract methods are already inherited actually. So what, how many of our abstract methods are there? They'll be inherited into the class bike. Now after they are inherited, this bike class will have two options. First option is it can make itself as an abstract bike. It can make itself as an abstract class, or it can give implementation for parent vehicle class. It can give implementation for parent vehicle class method. Okay, see, first way is you can make this class as an abstract, and you don't have to implement this dance method. You can make, first way of you utilizing this child class is, you can make this class bike as an abstract, and you don't have to implement anything, because inside a abstract class you will not have a method body. Okay, so currently this method is inherited to bike class, but we are not implementing it because of abstract. Okay, so this class bike is an abstract. Now who will give implementation? The next level of child, okay, for the bike will give implementation. Suppose if you go for bikes, now whatever methods were there in the bike class will be inherited to bikes class. In that get number of wheels, whatever the dance method we are seeing, right? So dance method also will be inherited. So these bikes will have two options. It can make itself as an abstract bikes. It can make itself as an abstract member. Okay, or it can give implementation for the parent abstract method. It can give implementation for the parent abstract method. So this is the routine task of your abstract class and methods along with the child classes. Okay. So I hope now you guys have understood. Everybody got it? Abstract class implement and abstract method extends. No, abstract method implements and abstract class extends. See, here for a class we are extending vehicle. For a method, for a method, what we are doing for a method? For abstract method, we are prefixing abstract keyword. Guys, don't get confused. For a class, if you are prefixing abstract keyword, it's an abstract class. For a method, if you are prefixing abstract keyword, then it's an abstract method. Rule is abstract method will not have any body because we are hiding it. Okay, we are not showing it. It's not like fully hidden. We are just not showing it because there is no use of it. Okay. And we have a child class bike which is inheriting vehicle class. Now bike has two options. It can implement this method, or if it doesn't want to implement, it can make itself as an abstract. So it doesn't want to make itself as an abstract, so it is overriding or implementing this get number of wheels method. So it is implementing get number of wheels method. After implementing, if you create an instance for the class bike, you can create instance only for this bike. You can't create for the abstract class vehicle, because for an abstract you can't create an object. For an abstract you can't create an for an abstract class for an abstract class for abstract class you can't create an object. You can't create an object. So that is why. Okay. Now, so here now we are creating an object for the class child bike class, and we are calling get number of wheels method. Okay, that's fine. Now, though we are upcasting here, new bike, we are still getting the details of get number of wheels method because of runtime polymorphism. Because of runtime polymorphism, which is the object currently executing in the RHS side. It doesn't matter what is there in the LHS side. It really doesn't matter. So, who is in the RHS side here? Bike class. Do we have get number of wheels method in bike? Yes, we do have. So, this is how you can create an instance for child of abstract class. Can create an instance of child of abstract class. Okay, so who can give implementation for parent abstract method? Parent abstract class method. Okay, parent abstract method, who will give implementation? Only the child classes of that parent class. Only the child classes of that parent class should give the implementation. Okay, so I hope you guys got it now. Everybody understood what is abstraction, what is abstract class, abstract method, how to implement it, what will have if parent is inherited into child. Everybody got it? Guys, did you get it? Let me know. Take one more example. Yeah, sure. I will take, don't worry. Yes, guys, I know. You guys want more examples. No problem. We will do it. No problem. Don't worry about it. Okay. So what we will do next is okay. So what we'll do is we will take iPhone. What is the current release of iPhone? Current release of iPhone, is it 15? Take slow. Yeah. Sanket, already I am going slow, man. I am repeating a number of times. I know I am going slow, or else you would have almost completed the syllabus by now. So we are going slow actually. Okay, let me take one more example. We will take iPhone 15. Okay, now let us ignore this iPhone 15. Now we shall go for creating a class that is iPhone 13. In the class iPhone 13, can you tell me one feature which is not there in 14 and 15? Can you tell me one feature which is not there in 14 and 15 iPhone 13? Yes, guys. What is the one visible change you can see from 13, 14, 15? One visible change. Yes, camera. So what we'll do is we'll go for an abstract method. Abstract int number of cameras. See, since this class has an abstract method, that is number of cameras, it's necessary to make this class also as an abstract class. Only abstract class can have abstract method. Okay, only. Okay, package name I've taken something else. Okay, guys. Okay, don't see package name. I have created abstraction, but it has gone to some other thing. Okay, don't worry about package name. Package name doesn't matter. Okay, abstraction we have not created. Okay, no problem. We can transfer it there later. Okay, just see the content. Okay. So yes. So currently we have iPhone 13. Currently we have iPhone 13 class, and in this iPhone 13 class we have number of cameras. We have number of cameras. Now this class iPhone 13 has to be implemented by what child class of it. Now what we will do here is, see, this is a abstract class. This is a abstract method. Now we shall implement it with the help of one class, that is iPhone 14. iPhone 14, iPhone 14 extends iPhone 13. Okay, now, what iPhone 14 is doing? It is inheriting iPhone 13. iPhone 13 is an abstract class and it has one abstract method. So, when iPhone 14 is inheriting iPhone 13, it is also inheriting this number of cameras method. It is also inheriting number of cameras method. Number of cameras method. So, iPhone 14 has two options. iPhone 14, iPhone 14 has two options. That is, iPhone 14, if it doesn't want to implement this method, that is, if it doesn't want to implement this number of cameras, it doesn't want to give method block for this number of cameras method, this iPhone 14 can make itself as an abstract. iPhone 14 can make itself as an abstract class. Now, compiler will not force the class to override this camera method. This method it will not force, because why? In abstract class you can't have a method with a block. Method body you can't have. So this method now currently it is present in this class also. This method, it has been inherited. This the whole iPhone 13 class has been inherited into the iPhone 14. Now this method number of cameras is also present in here. So first way for this, I mean there are two ways for iPhone 14 now. If it doesn't want to implement this number of cameras, it can make itself as an abstract class. But but if the iPhone wants to implement this number of cameras, you can implement. So how many cameras were there in iPhone 13? I mean, sorry, in iPhone 14, how many cameras were there? Really? iPhone 14, five cameras were there. Okay, three was there. Yes. So two were in the bottom, I mean, from top to bottom, and one was in the side, right? Okay. So here, to override, now we are overriding. See, there is two options for the child class. The child class, which is inheriting the abstract iPhone 13, has two options. It can make itself as an abstract and not override this method, and it can override this number of cameras method, and it can return the data. It can return the data. See here, iPhone 14 is now going for the second option. It is overriding the method and it is giving a implementation. But iPhone 14 has one more option. It don't have to implement, and it can make itself as an abstract. It can make itself as an abstract class. It can make itself as an abstract class. Okay. So how we can make it as abstract? You can make this child as an abstract because it's inheriting abstract iPhone 13. Now Your compiler will not tell to implement this number of cameras method in this abstract class, because inside abstract class you can't have a method with a method body. With a method body you can't have, or with a method block you can't have. Next, if this class also rejects to not implement this number of cameras method. iPhone 13 has number of cameras method. Now this class iPhone 14 doesn't want to implement this number of cameras method, so it has become abstract. So when it become abstract, now the next level of child, okay, next level of child, okay, should give the implementation for this abstract method. Next level of child should give implementation for this abstract method. Okay, now now iPhone 15 extends iPhone 14, extends iPhone 14. Okay, now see, there is two options for this iPhone 15. What is the two options? Either it can implement the unimplement method, that is number of cameras, or it can make itself as an abstract and not implement that method. Two options will be given when you inherit an abstract. See, this iPhone 14 is also an abstract class now. Now when you're inheriting abstract class, there will be two options. Either you can add an unimplemented method here. Currently, this number of cameras is present in iPhone 13 also, in iPhone 14 also it is present. Now in iPhone 15 we have two options. If you want, if you don't want to implement this method, you can make this class as an abstract. You can make this class as an abstract and not implement this number of cameras method. You can make this class as an abstract and you don't have to implement this method, and the next level of child will implement this method. But in case this iPhone 15 wants to implement this number of cameras method, then we can implement by overriding. We can add an unimplemented methods now. Okay, so now we are giving implementation of method body for the number of cameras method. So can you tell me what is the number of cameras in iPhone 15? iPhone 15 number of cameras? Yes, it is 2 only. Yeah. Now, now listen carefully. Listen carefully. When you create, when you create, when you create object for the iPhone 15. Now let us create an object for iPhone 15 now. So iPhone 15. Okay, I15 is equal to new iPhone 15 of no argument construct. Now using iPhone 15 variable, I15 variable, okay, I15 dot number of cameras method. So obviously we will be getting the output, that is 2. Okay, whole phone is camera. Whole phone is camera. Whole phone is camera. Okay, okay. We are just taking one feature of it. Okay. So iPhone 15, we have created an object for iPhone 15 and we got the output 2. Now let me show you here. Can you see 2 here? Yes. Now in the iPhone 15, now we have just called the number of cameras method. We are able to access it because we have overridden here. Now you can even upcache to iPhone 14 also. You can even upcache to iPhone 13 also. That is possible. Why? Because of runtime polymorphism. What we have done here, method overriding. So now if you upcast also, suppose if you go for iPhone 14, I14 is equal to, okay, new iPhone 15. You can't create an object for iPhone 14 and 13 because both are abstract class. For an abstract class, you can't create object. But you can upcast the iPhone 15 to iPhone 14 also you can upcast, and to the iPhone 13 also you can upcast. Okay, so iPhone I14, okay, and we are upcasting the child 15 to 14. We are upcasting child reference to parent reference. Okay, since parent is an abstract, it will not able to create an object for parent. Now we shall go for I14 dot number of cameras method. Still you will get 2. Why? Because there is a runtime polymorphism happening here. Can you see here? Who is the runtime object? iPhone 15. So iPhone 15 data only you will be getting, because of overriding. Because of overriding, and runtime polymorphism. In runtime polymorphism, we can achieve runtime polymorphism with the help of method overriding. And in runtime polymorphism, you have to see RHS side, which is the currently executing object. Okay, only that object members will be executed, and it doesn't matter what is the type of reference given. It doesn't matter what is the type of reference given. Okay. So now you can even upcast to iPhone 14, and you can even upcast to iPhone 15 also. Okay. iPhone 13 also you can upcast. So iPhone 13. So I13 is equal to new iPhone 15. Now we shall go for I13 dot number of cameras. Still you will get 2 only, because control goes to that classes. Okay, that abstract classes control goes, but here runtime object is who 15. Here also who 15. Here also who 15. Because we are doing a runtime polymorphism, after we override whatever the data is there, that's the final, and whatever the overridden method is there, and that overridden method will be taken as an output. Okay, you have to just see what is the object currently executing. Okay, which object is currently getting executed in the RHS side. Okay, that object data only will be executed. Now if you execute here, you'll be getting triple two. Triple twos you are getting. Okay, so this is how you deal with your abstract class and abstract interface. Yes, you guys got it? Everyone understood at least now? Everybody understood? Let me know. You guys got it or not, guys? Let me know. Okay, any doubts in this abstraction? We have just started. Any doubts is there? You can let me know. Okay, I think no doubts. Okay, now let us proceed to the um concrete class and concrete method. Okay, you have to know about concrete class and concrete method. It's very important. Okay, so okay, so we shall understand what is concrete class and concrete method. See guys, till today, before abstraction, whatever the classes we have created, okay, whatever the classes you have created, those all classes are called as concrete class. What all classes we have created till now, whatever classes we have used, those are all called as concrete class, because a concrete class is a class which is not prefixed with the abstract. A concrete class is a class which is not prefixed with the abstract keyword, and it doesn't have any abstract methods inherited. Any abstract methods inherited also it doesn't have. It's either in the declared format also, declared or inherited. Declared or inherited. Any class, listen carefully, any class which is not prefixed with abstract keyword and it doesn't have any abstract method within it, either in the declared format or in the inherited format. In declared format also, in inherited format also, if there is no abstract method in a class and a class is not prefixed with abstract keyword, then you can call that class as a concrete class. Then you can call that class as a concrete class. Okay, and in our Java, we can create object only for concrete class. Object can be created only for concrete class. Only for concrete class. Okay. Now, next, we have to understand about concrete method. See, guys, in your example here, you can call this method as a concrete method. Why? Because this method has a brackets or method block it has. And you can call this as a concrete method. Why? Because this method is giving implementation to this parent abstract method. Parent abstract method is implemented here. Parent abstract method excuse me excuse me Okay. So parent abstract method is implemented in the child class. Is implemented in the child class. Okay. So this is what we I mean this method is called as a concrete method. This method is called as concrete method. See, parent class abstract method, we are overriding in the child class iPhone 15, and we are overriding that method and we are giving implementation. By overriding, we have given even implementation also, which means here in the number of cameras, here we have created a method block or method implementation. Method block or method implementation we have created it. Okay. Now you can tell this method as a concrete method. Why? Because this method is giving implementation for this parent class method. This method is giving implementation for this parent class method. That means in this parent class method, that is abstract method, there is no implementation. But this child class iPhone 15 is providing a implementation. Okay. And okay. Now Now, since it's providing implementation for the parent class abstract method, you can call this method as a concrete method. And you can call any method as a concrete method. How? You can call any method as a concrete method if it has a blocks. You can call any method as a concrete method if it has a blocks. Okay? You can call it as a concrete method. Any method which is having a method blocks is called as any method which has a method blocks is called as concrete method, and you can call a concrete method to the method which is overriding your abstract method. Now this abstract method is overridden by this method, so you can call this method, this overridden method as a, you can call this overridden method as a concrete method. Okay. Now to understand this, let us do one design. Okay. Means main method is a concrete method. Yeah, you can call main method also as a concrete method. Yes. Yes. So listen here. Okay. Okay, we will see that later. Yes, main method is also called as concrete method also. Okay. And usually we will not go for main method because main method is static. We will not tell main method is a concrete method because it is static. Only for non-static methods I'm telling you. Okay. You can have static methods, but here main method is static and you can take any non-static method as a concrete method. Okay. So any method, any abstract method, if it has been implemented, that method you can call, that overridden method you can call it as a concrete method. By definition, this is what it is. A method which give implementation to the abstract method is called as concrete method. And concrete method means any method which has a blocks. Any method which is implementing or any method which has a blocks is called as concrete method, and you will get to know this once you go to interface. Okay. So any method which has a block, you can call it as a concrete method, and only non-static. You can't tell this main method as a concrete method because it's not overriding, it's not implementing any method. Okay. So you can't call main method as a concrete method, it's just a normal method. And you can't even write main method inside your iPhone 14 because it needs an implementation. Okay. So it should not be written. Okay. In the abstract methods, in no method, either it's a static or non-static, it should not be written with the method block. See, we have a non-static method, it is of without method block, right? And here also it is without method block, and here it is with method block, which means we are overriding this non-static abstract non-static method. This method is called as a concrete method. And concrete method, why we are calling concrete method? Because it has a method block. Since it has a method block, we can call it as a concrete method. Okay. So now what we will do is, let us go for one design now. Okay, let us go for one design. Okay. And mainly remember one thing, you can't create object for abstract class. You can't create object for abstract class. What is this, ma'am? Means in concrete method only non-static we will take. Yes, concrete method means usually if you're going for object oriented programming, everything will be non-static. Non-primitive, non-static only it will be. No static will be there. Static is a primitive. Okay. It's a you can see that until your compile time polymorphism. Okay. Now you can't go for Here, see, static you can't write. See, why? Because static has already a block. This main method is already having a block. If it is allowed inside abstract, see, we have to achieve 100% abstraction, right? We have to achieve 100% abstraction. If you write a method with the code, then what is the use? You are showing that to user, right? You're showing that to user. The thing is, you should not show that to the user. Okay, but the child classes of the classes can override that method, and it will not be shown to the user. It will not be shown to the user. Okay, now, okay, I hope you understood. Concrete method means the method which give implementation to the abstract method. To this abstract method. Okay, just remember, to this abstract method. Okay, any method which is giving implementation is called as concrete method. Okay, so usually we override non-static methods only. We don't override static methods. Static is a compile time polymorphism. This is runtime polymorphism. Non-static methods, if you're using, that is runtime polymorphism. Static methods you're using, that's a compile time polymorphism. Static methods we are not using here. We are using it in a normal class. We don't take the static methods here. Okay. So hope you have understood. Now what we will do is we shall create one design and understand how abstraction is going on. Okay. So we will create one design now. So what we will do is we shall go for one ATM design. Okay, one ATM design will go for. In that we'll have an ATM class. In class ATM, it will have withdrawal, deposit, balance inquiry, and change password. And below that we'll have one ICICI ATM. Okay, ICICI ATM we shall have, and without account it's not possible to proceed, so we shall create one class account. We shall create a class account here, and here account is dependent on the ATM, so we shall go for has a relationship here, and the level of dependency is okay. You can go for aggregation only. Why? Because account can stay without ATM also. Account can stay without ATM also, so we are going for aggregation. Okay, next. Now we shall go for your class names. So you have a class ATM here, class ATM, abstract class ATM. In that you have withdraw method. Okay, for withdraw we'll go for different colors. Okay, we have ATM method, and here you have ICICI ATM method, and you have your account class. Okay, so ATM class, ICICI ATM class, and account class we have. Now we shall go for the elements of ATM. So we can go for withdraw method, and at the end, if I'm giving semicolon, which means it's a abstract. Okay, now deposit. Next, balance inquiry. Then we shall go for change password method. Change password method. Shall write it neatly here. Okay, in the ICICI ATM, we have two options, that is two methods, that is create account method. And this will be a normal methods, and we can go for deactivate method. Okay, now in the account number class, we shall go for account class, we can go for account number. Okay, next we shall go for password, shall go for balance. So currently we are taking this as a normal account. There is no private, just for normal. We are just taking to understand your concrete members. Okay, I mean the abstract methods, how it will be implemented. So we are seeing here. Now listen carefully. This is our design, and here we'll be involving abstraction. Abstraction will be involved here. Okay. Now this ATM is abstract. ATM is abstract. So let us take a snap of this first. Okay. Shall we change the color here? Um, Okay, it's a bad idea. Okay, so we shall just take the snap like this itself. Okay, now what we'll do is neatly we'll start with our code. Now listen carefully. One more thing, you can never create an object for abstract. You can never ever ever create an object for abstract class. Now we shall go for your design now. So first one we can go for your class ATM. Okay, abstract class ATM. As you can see in the design here, you can first go for this abstract class ATM. Okay, now listen carefully. Listen carefully here. Now let us create one. Okay, we shall now currently we'll go for abstraction and directly we'll do it here. Abstraction, and we'll go create one class here. So we shall go for class ATM. We create one class ATM here. Now currently we have one class ATM. We have a class ATM here. Now in the ATM class we have four abstract non-static methods. We have we have four abstract non-static methods. Okay, four abstract non-static methods are currently present in this ATM abstract ATM class. See, this ATM is an abstract, so we shall write abstract keyword. Currently this ATM is an abstract. Okay, now we will have four abstract methods here, that is public, abstract, void, withdraw method. So for withdrawing you need a password, int password, and for withdrawing you need amount also, so double amount. We shall go for semicolon. Okay, now this is what we call it as a abstract method in an abstract class. Withdraw is an abstract method, and at the end you have to give the semicolon. So like this we shall create some more three methods. Public abstract word, you can go for deposit method. So for depositing also we need a password, and for depositing we need how much amount to be deposited. Okay, next depositing is done. Now we shall go for balance inquiry. Balance inquiry. So for balance inquiry you just need a password, int password we need, that's it. Next we shall go for one more method, that is change password. Change password. So you need to enter old password and we have to enter new password. Guys, you remember we have done one application like this. You guys remember for SBI? We have done for SBI. You guys remember? For SBI design, we have done a big design for SBI, and all these operations are involved there. I really hope you guys remember. Okay, so same like that only, nothing changed. But here, this whole ATM class is an abstract. It's an abstract class, and what all the methods is there here are all abstract non-static methods. Okay. So these are abstract non-static methods. Okay. Now, in the design, we have done with ATM. Now let us go for account class. Okay, ATM is done. We shall go for class account. So class account. Now account has account number, so long account number. Next we shall go for password, so int password, and balance, so double balance. Now we want to create a constructor for this class account. Go for source, generate constructors using fields, and generate. So now we got a beautiful account constructor. That's all in the account class. That's all in the account class. Next, We shall go for ICICI ATM. We shall go for class. We shall go for the class ICICI ATM. ICICI ATM class. Okay. Now, um, okay. So we should go for the ICICI ATM, and we will just take one different class for this. So ICICI ATM class. Now this class extends ATM, extends ATM. So when you tell this class extends ATM, when you tell that the class extends ATM, means from this class ATM, from this abstract class ATM into this ICICI ATM, the four non-static abstract methods are being inherited. Into this ICICI ATM class, the non-static abstract methods from ATM class have been inherited already. Already they are inherited. Okay, inherited already. Now, next, what we have to do here is, see, you should not forget the UML design. Never forget UML design. See, you have an ATM. Okay, for the ICICI ATM, you did extends ATM. But what about account? Account is having has a relationship with the ICICI ATM. So to make sure it is having has a relationship, we can take account and we can mention here account key. Done. So we have achieved a has a relationship here. As a, okay, you can just tell achieve as a relationship. Next, now we shall go for creating account method. We shall go for creating the account method. So how to create an account? See, since we have an has a relationship here, okay, and the level of dependency. Now can you guys tell me what is the level of dependency here? Level of dependency between account and the ICICI ATM. What is the level of dependency here? There is a has a relationship going on between account and the ICICI ATM. Now what is the relationship between, okay, what is the dependency between your account and ICICI ATM? See the design, see the empty diamond. Now tell me level of dependency. Yes, it's an aggregation. Correct. It's not a composition, it's an aggregation. So when it is an aggregation, we shall go for a later lazy instantiation. We shall go for later lazy instantiation. Now what we'll do is we'll create one method called as create account method, and we'll pass this account A inside that. Okay. Now we shall go for public void create account method, and in that we can place account. Now we have achieved later lazy instantiation. Achieved later lazy instantiation. Okay, so here we have an account A and we have achieved has a relationship and extends ATM for this class ICICI ATM because we inherit ATM members. So ATM has four abstract non-static methods which has been already inherited to ICICI ATM. That is why we are getting red mark here. So currently in ICICI ATM we have two methods, that is create account and the deactivate. Create account and deactivate we will inherit it from, we will override the methods from ATM, but first let us create an account here first. So create account method, we have to check if account is there or not. If this dot A is equal to null. If there is no account, we will create one account like this dot A is equal to A, and we have to tell account is successfully created. Same logic, account is successfully created. And if not, if the account is not there, then we can tell, I mean, if the control comes to else block, we can tell account already exists. Account already exists. How? If there is no account only, we have created account. When this condition become false, which means this account is already there. When the condition becomes false here, obviously account is already there. So when it is there only, control comes to else and you'll be getting account already exists. Account already exists. This is about create account method. So let us take the cursor to the ICICI ATM and let us add a unimplemented methods. Can you see here withdraw, deposit, balance inquiry, change password? Can you see the four methods from the parent class? Parent class ATM? Yes. We can see these four methods. Now let us go for withdrawing. Okay. So shall I give you an homework now? Shall I give you a homework? Yes. Everyone, can you take this homework? See, I have already implemented ATM class. ATM methods are already implemented here. Now your task is whatever the logic we have seen in SBI, no, same logic you go for withdraw, deposit, balance inquiry, and change password. And create one driver class. So SBI driver class we have created. No, you remember in the same way. For this, you create one ICICI ATM driver class. Create one ICICI ATM driver class and what all customization we have done for SBI, what all customization we have done for SBI, same customization you do here. See, already we have the design here. So we have ATM, okay, we have a class abstract class ATM. We have four abstract non-static methods and we can't create an object for ATM. Okay. Now we have class account, attributes, and the constructor is there done. Now, now in the ICICI ATM, ICICI ATM inherits ATM and it yeah it will it has a relationship with the account. ICICI ATM inherits ATM and has a relationship with the account and has a relationship with the account class. Next, here, since we have, I mean, we have to achieve has a relationship, we have mentioned account A here, and to achieve later less instantiation in a create account method, we have placed account object and we have checked if account is not there to create on, and if account is already there, we will tell account is already there. And you have taken cursor and placed on the ICICI ATM. Now the four abstract non-static method from the parent class, the four abstract non-static method from the parent class has been implemented here. Okay, has been implemented here. and and the code whatever has to be written inside, okay, they will be they will be written by you. Okay, whatever the code inbuilt you have to write, no, okay, here whatever in between you have to write, that will be written by you, and you have to create one driver class and come. Okay, that is your homework for today. Will you guys do and come? I will check tomorrow. I will surely check tomorrow. Will you guys do and come? All I have done, everything I have done. Extra one thing is you have to implement the logic here. Whatever you have seen in SBI, no, same logic you implement here also, and you create one ICICI ATM driver class. Take input from user. What all the customization we have done, no, you do it. See, repeating here is we have created class account. See here, everyone listen carefully. Once again. Okay. So here we have created ATM class with four abstract non-static methods. We have created account class with the attributes and the constructor. We have created ICICI ATM along with the create account method and deactivity spending. We will do it. Create account method. Okay, deactivate. I will write it now. Okay. Now, now here, what all the non-static methods will be inherited to from ATM to ICICI ATM? We have already overridden, but the logic of overriding I have not written. Logic, these methods will be inherited here, and you have to override it and write the logic. That logic I'm leaving it to you. And after creating ICICI ATM, create one ICICI ATM driver class. And in the driver class only import scanner class, take input from user. What all customization we have done for SBI driver class, what all we have done customization for SBI driver, same customization you go for ICICI driver. Same customization you can go for ICICI ATM driver. Everybody got the homework? Everybody understood? Yes, Preeti got it? Okay. Okay, guys. Anywhere, any doubts you have for today? Anywhere, any doubts, you can let me know. Anywhere, any doubts? In case if you guys have, you can let me know for today's concept. Anybody? And mark is there, right? Oral mark is there. Oral mark is pending for you. I thought of taking last 10 minutes, but I forgot. Tomorrow we'll take oral mark. Make sure you study and come. Okay? Make sure you study and come. For part one, at least I've not taken, we'll take it. Okay, taken. Okay, let me check just a minute. Let me check how many of you have given. Yes. Few peoples are pending. Okay, I will take it. Don't worry about that. I will. That's my job. I will take it. Make sure you prepare and come. Okay, for part one only, right? So prepare and come. Okay. Yes, guys, that's it for today. And I see you guys in tomorrow's class with your homework. Very easy homework I have given. Already you have code. Okay. No, no, no. I can't share points here. No, no, no. That ratings I can't share. It will be given to your HR. Or else, if you want separately, you can ask me in the Q talk. If you want your mark ratings in group, I will not give because everybody are here. So in group, I don't give marks and I don't tell results. So that's the etiquette I am following. Okay. Yes, separately I'm asking. Oh yes, yes. Separately you can ping me on the Q talk. I will send you. I will send you for sure. Okay. Yes, guys, that's it for today. And I'll see you guys in tomorrow's class. Make sure you do the program and come. What is this? Okay, guys, that's it for today. Mark rating I will send you. You have to ping me, or else I can't find you separately. There are so many batches. There are so many people. Not only your class is there. Okay, there are so many people. I'm not degrading you, but you ping me. I also will forget. I also will forget. I have to send you notes. So many other things also will be there. So you ping me. I will send you. Okay. Okay, guys, that's it for today, and I'll see you guys in tomorrow's class with your code. Okay. Okay, guys, have a great day. I mean, great night. Take care, guys. Bye bye.